This is the lecture for section 1.3, properties of functions, specifically symmetry properties. So let's begin with a review of what we did last time, sketching the graphs of functions. So in this problem, we're asked to sketch the graph of the function y equals f of x equals 2 minus x squared. We're going to plot at least 5 points and be sure to show a scale on the axes. So let's get started plotting some points. So I'm just going to start with those 5 points that we usually use and see how it works out. And if I need more, I'll choose more. So I'm going to take the -2, -1, 0, 1, and 2. And then for each point, I'll be plugging it in to the graph, I'll be plugging it in to the equation that we're given. So like when I'm going to find y for x equals -2, that means I'm going to find f of -2, which is 2 minus -2 squared. So this is 2 minus 4, because -2 squared is positive 4. So this one is -2. Okay. Similarly, f of -1 is 2 minus -1 squared, which is 2 minus 1, which is 1. F of 0 is 2 minus 0 squared, which is 2 minus 0. So that's 2. When I plug in f of 1, it's 2 minus 1 squared, which is 2 minus 1, which is 1. And then the last one, f of 2, is 2 minus 2 squared, which is 2 minus 4, which is -2 again. So I'm going to go to make my sketch, and then as usual the x and the y axes are there. Actually, I see that both x and y could have similar scales, so I'm going to just count by ones on both the x and the y-axis in the positive and negative direction. Actually, y never got, oh yeah, y did get negative, excuse me. So I'm going to put the negatives on the x and on the y-axis. And then I'm going to plot these points. So I have the point -2, -2. I have -1, +1. I have 0, 2. I have 1, 1. And I have 2, -2. So essentially what this graph looks like is like this. Okay, so this is the graph of the function. Again, like, pardon my squiggly line, I struggle with drawing on the tablet with the stylus. It's a little clunky, but I think you see the basics. And so the next question is that just for this function, what's the domain, range, the x-intercepts, and the y-intercepts? So the domain is all real numbers, because I can plug any value in for x, and the range is only the y values that are coming out. So this is the range. It doesn't ever seem like it gets higher than 2. So the range is all the way from -infinity up to and including, but not going past, y equals 2. Okie dokie. So in terms of the x and the y-intercepts, so I can kind of see the x-intercepts here and here. I can guess that it's some number between like 1 and 1.5. But if I really want to know what it is exactly, I need to solve the equation. So remember, the x-intercept is the value of x for which y equals 0. So I want y equals 0. And remember, at the same time, y is equal to 2 minus x squared. So I'm going to solve 2 minus x squared equals 0 for x. So if I add x squared to both sides of the equation, I will get x squared equals 2. And if I take the square root to both sides, I will get x equals plus and minus the square root of 2, which is like approximately plus and minus 1.4, which matches the guess that we made based on our graph. And to find the y-intercept, that just means when x equals 0, I have to plug it in. And in fact, if you remember, we did that already, and you can see it on the graph of the function. So I don't need to repeat my computation. I know that the y-intercept, which is when x is equal to 0, is 2. Okay, so the y-intercept is 2. All right, so partially this is just a review. I like to start with a review sometimes, but also it's to motivate the discussion question, which is to describe the graph of the function. Does it have any symmetry? So you might have noticed that, like, when we plug in 1 and -1, we get the same thing out. And when we plug in 2 and -2, we get the same thing out. So that's kind of causing us to have these 2 points on either side of the y-axis that basically are mirrored. So there's like a kind of a symmetry about the y-axis. If I were to fold the graph over itself on this piece of paper, if you can imagine that, then all the points would lie on top. Okay, so this has like the y-axis symmetry, which is also called the even symmetry. So that's this definition right here. A function is called even if it's symmetrical about the y-axis. So algebraically, that means that f of x equals f of minus x for every x in the domain. Okay, if you're not like familiar with it yet, this one right here, that upside down A looking thing, means for all or for every. Okay, so it's not enough if you just plug in a couple points, because you could have a graph that was symmetrical at those points but not symmetrical at other points. So the only way you're going to be able to tell is either to plot points and produce the graph, or to check this definition, which is highlighted but in letters, not in numbers. Okay, so for number 2, you see the question asks, is f of x equals x squared even? So let's check our answer. First, we can check it graphically. Oopsie, I don't know, sorry about that. Okay, so if we do something similar to what we just did, I'm going to plot x and then y equals x squared for my 5 points to start. So when I plug in -2, I'll get 4 when I square it. Okay, so I get these points, and then when I go and I sketch my graph of x squared, we can look and see what does it look like. Okay, I'm going to count by ones on the y-axis up until 4 for the points I have. So I'm making like a quick sketch. Take your time, but this is more just to illustrate the symmetry question, yeah? So this is what the graph of y equals x squared looks like. So you can see that it is symmetric to the y-axis, and then from that, that means that it is even. So you can do a quick sketch and see if it has that kind of symmetry. That's like the graphical approach. And then the other option is the algebraic or symbolic approach. So this will be using the highlighted definition. So we're going to compute f of x and f of minus x, and we're going to see whether or not, we're questioning whether or not they are equal. Okay, so f of x, by the definition, equals x squared. And f of minus x, so first of all, by the definition, it equals minus x squared. And then by simplification, this is minus x times minus x. So this equals x squared. So then you check and you see, are they the same? In this case, they are the same. And so that means that the function is even, which we already knew, but now we saw it a different way. So like you wouldn't have to prove it two different ways, but this is just, you can choose which way makes the most sense to you, or depending on the problem, it might be like really hard to do one way or the other. Maybe we don't know whatever the graph looks like, so then you would have to do it algebraically. So, okay, so that's the introduction to even functions. I'm going to pause this video and make you another video about odd functions.